Welcome, folks. Thanks for joining me in this session on navigating Android like a pro. If you don't know me, I'm Vivek. I work on a company called as Freshworks Studio. We are based out in Victoria. Just a quick study, how many of you have already worked with Jetpack Navigation components? Okay, that's a lot. Okay. Sure. This talk, I'm going to touch upon the features that were there in pre-alpha 1.0 alphas, and then we'll go through what are the features that are available right now in 2.1 and above. So what is navigation? 2 years back, before all the Jetpack navigations came alive, we all did navigations differently. Some of us wanted to do it better. We created argument classes. We created utility methods to reduce boilerplates. We did all sort of magic. And some of us just went wild with starting activities using intents and fragment transactions. There wasn't a particular way, a streamlined process where everyone sort of gets along. It happens. It was different in all of the projects. And Jetpack Navigation component aimed to solve it. It's an opinionated library. It's not the only way where you can provide navigation for a project. It's one of the ways where you can streamline the navigation of your screens. That's the main goal of this component. 1.0 was stable earlier this year, but was introduced in IO 18. Along with other Jetpack libraries. 1.0 had a lot of issues. So as a developer, as an Android developer, I went on board with the alphas and betas before it even became stable, so that's my fault. But still, I was so excited when 1.0 came up, and I was like, okay, I've got to try this out. And then, fortunately, I worked on an application which just started out. So I started implementing navigation graph, and I had to revert back within a month because it didn't have all the features that I needed to make the entire app migrate to the navigation components. So what were the issues? One thing, it took 1 year for the stable. It is understandable, but as a developer, when you're stuck with alpha and beta for a year, then you have got to wait for their updates, and there were a lot of issues with the alphas and betas as it's supposed to have. And 2.0 was released right at the time of 1.0. It was essentially the same thing, but with a couple of Android X migrations done. There was no feature added over there. And it also was not feature-rich as it is now. So a lot of features like dialogues, deep link navigations were not there. So what's there now? What's the current status? So we have a lot of versions right now. 2.1 is currently the stable version. 2.2 is in a release candidate phase where I last said, and 2.3, it's announced in the recent Android Dev Summit, and it's a developer snapshot. So it's not even in alpha right now. So what are the features that were introduced in the 2.x versions of Jetpack Navigation component is, one of them is you can create a view model that's scoped to the nav graph. We usually create a view model that's scoped to either the fragment or the activity, encompassing activity. But you can also now create a view model that's alive for all the destinations within a particular nav graph. You can also support dialog fragments. Earlier, dialogs were not considered a part of your destination. Dialogs are now a part of your nav graph as well. You can provide deep link support. If you're one of a kind and want to go with custom view-based screens instead of fragments and activities, then you can have a custom nav controller where you can support custom view-based navigations as well. And in 2.3, we also have dynamic feature module. So it was introduced right last month. So let's start with the basics. Everything with Android starts with dependencies, right? These are the two lines that you have got to add to your build.gradle. Most of you, since you have already worked with it, I don't think this is going to be any useful for you guys. But still, if you're still in Android, if you're still in Java land, then you just ignore the KTX versions, and that's it. My talk is going to touch upon the basics, and we are going to cover everything that's there in the navigation components library. So the basic building block is the navigation graph. The navigation graph is an XML resource. You can create it under resource directory. there is a, I mean, you create a folder called as navigation, and you create the XML file. They are all, I mean, it's all streamlined with Android Studio, but as all developers, we don't really like the GUI, and we play wild with XML. So my talk is going to concentrate on XML part of the navigation graphs. We are not going to touch upon the UI things, but the developer documentation has got a lot of UI-related steps as well. So it's not supposed to be clear, but this is a navigation graph that we have for one of our medium complex applications that is live right now. Let's take a closer look here at one of the navigation graphs, a part of the navigation graph. You see a couple of boxes, and you see a couple of arrows. So the boxes are called as destinations, and the arrows are called as actions. Destinations are supposed to be any Android component like activities, views, dialogues, and so on and so forth, while the actions are the way where you can transition from one destination to another. Actions contain a lot of metadata about the transition, and we'll see about that during this talk. And you have got your navigation graph. How do you link it with your application? So you have an activity, you just add a fragment, and the fragment has the fragment class is navos fragment. So navos fragment is a part of the Android Jetpack component. You just add the name and resource there. If you see the last line, the nav graph navigation, you link the navigation resource, and this takes care of getting the navigation component set. We'll see how all of this works. I'm just going over the basic overview right now. Let's go deeper into the destinations. They are the basic building blocks of a nav graph. And we also support activities, fragments, dialogues, and there is something called as placeholders as well. So this is how you define an activity destination. It's a simple ID. And activity destinations or terminal destinations. So each nav graph is supposed to have its own, each activity is supposed to have its own nav graph. So activities or terminal where any destination can lead to an activity, but activity cannot open up another destination. So as all things with Android, we give it an ID because we love IDs. And we then give a name. So this is how we link the activity that we wrote, the activity source code that we wrote with the activity destination here. So we just say the name of the fully qualified name of the activity here. You can give it a label if you want. It's an optional attribute. And this is a nice little line where if you saw the navigation graph example that I showed earlier, it said preview unavailable on each of the screens. I had to cut it out because it's a production app. But you can use this thing to say, to see your layout in your navigation graph. So if you do this, it's not out of the box, but you have to specify which layout the current destination has, and that's how a navigation graph would show you a nice little preview of your screens. The next one is fragments. So it's the same thing as Android. You just say a fragment tag with ID, name, label, and layout. This is how it would look on a navigation graph. So it has got the ID at the top, and it shows a nice little preview. And then dialogues. So this is one of the features that was introduced in 2.1 and above. Dialogue fragments, there is no support for dialogues or action dialogues. There is support for dialogue fragments alone. So how it works is whenever you navigate to a dialogue destination, the dialogue fragment shows up. And whenever you navigate out of the destination, then the dialogue automatically closes up. So you don't have to say dialogue fragment.show or dialogue fragment.dismiss. It does it automatically. And it doesn't keep the fragment, since it's still a fragment, it doesn't keep it in the backstack. And when you go back out of the destination, it clears the backstack, clears the destination from the backstack. And this is something called as a placeholder. So if you're like me and you want to lay out your navigation architecture first and then go back into your application development, you want to see your entire navigation flow in one place before you get onto the development. I would recommend this one because you can clearly define which screen you want to be developed first. You can just say fragment or activity or dialogue or something and give it an ID. Notice that there is no name parameter here because we haven't developed it yet. So we just say ID, and if you want, you can run it out. What happens is this is something called as a placeholder. So I mean, it's marked with an X over there. If you run it, it would compile, it would work, it would run. If you try to navigate to that particular destination or an action, then it's going to cause you a runtime crash. So if you want to navigate, then you just create your class and then add the Android name attribute over here. And you added the fragment, Navos fragment in your activity, and you referred, you sort of linked it with your navigation resource. But how do you say which fragment to open up first? So that's how that's where this comes into play. You say start destination and give it an ID of the destination if you want something to be opened as soon as the navigation Navos fragment is added to your activity. So that's the basics about destinations, and the next one is actions. Nav action is an auto-generated class. So for each action, for each arrow that you have in your navigation graph, a nav action, a class extending nav action is going to get generated. And it holds the metadata of all the things that you need for a transition to be like proper. So it contains the details of the target destination, which destination you want to open up, which activity or fragment you want to open. It also contains the arguments that you want to pass, like the bundles and other stuff as well. It also contains nav options, so that's one of the important things. So that's where you can provide the animation if you want to do a shared element animation, or if you want to specify an exit and enter animations for your destination, or if you want to modify the backstack behavior, or if you want to modify the launch mode, such as single top, or if it's not a single top or something like that. So these are the important details that are packed into your action. And this is how action would look like. Let's get into this deeper. It's a lot of code. An action is here. We have an action called as launch members fragment, and that's inside a home fragment destination. And we want to open up the members fragment, so we specify the ID and the destination here. And then we also specify the animations. As I said, the actions contain the animation behavior as well. So we can say enter animation, exit animation, and what's the animation that you want to do when a pop operation is performed, and you lead back to this destination. Also, you can also specify the pop behavior on what to do when the action is popped up. When the destination you are in, when you press a back. Let's assume that we came from home fragment to members fragment, and you can configure here what happens when you press back button from the members fragment. So you don't really want to go to home fragment, but you want to go to some other place, then you can specify that here. We'll see about this in a minute. But before that, global actions. As I said, actions are typically used to open up a destination. We saw the previous action that we saw here is nested within another destination, right? So instead of that, there are cases where you want the destination to be reachable from all other destinations. You don't want a one-to-one, you want an end-to-one connection for that destination. This is the case where you want to open up a settings page or a home page or your login page from any screen of your application. You can just provide an action for that destination. So you just say launch home action and with a destination, and you would have a nice little arrow to that destination. That means that this is a global action, and any destination can call this action to launch that particular fragment. So this is kind of useful for conditional navigations as well, where you want to open up the login fragment whenever there is the user is not authorized, and you want them to go back to the login screen and then come back here. We saw about destinations and actions and how they bond together, but the most important thing in an application is no two screens are like independent. We always pass around data, we always save data somewhere and then retrieve them somewhere else. So that's how our entire sleep goes, right? We struggle a lot with passing around arguments. So one of the things that happens to me a lot is I forget the key identifier of the bundles that we pass around, and we also don't know the type of the bundle identifier. So let's say that we are passing in the member ID. It doesn't matter if it's a string or an integer, and you have to remember what's the type that you're sending it to, right? There are a few ways with navigation components where you can solve those things. This is something called as an argument tag, so you can add it to a destination or an action. Argument takes in 3 parameters: the name, the type, and the default value. The type could be anything that is supported by a bundle. So it could be an integer, it could be a string, or it could be a class that extends parcelable, serializable, enums, and everything as well. So what you can do is you can create an argument tag inside the destination. So if you create it inside a destination, that means the argument is available for all the actions that are using this destination. If you're creating it to a particular action, then that means you can use that argument with just that particular action. But this is all too much. I mean, we don't really want to worry about this. So that's why safe arcs come into play. Safe arcs is a cool little Gradle plugin that's packed along with Jetpack Navigation components. You just had to add a class path and apply the plugin in your app level bit.gradle. The only thing is you need Android Edge support for your application. So if you haven't migrated yet, then this is probably the time where you migrate to Android Edge. So once you do that, what happens is safe arcs create you the type safe argument classes. Instead of just working with bundles, you get to work with real classes with real types, and you don't have to do the guessing work anymore. So what happens is it creates 2 different classes. One is directions class, and the other one is argument class. So each action has got 2 destinations. So one is the source destination, and the other one is the target destination. The source destination has a generated class called as the source destination name directions, and it has got a member. I'm just going to go into the example so that it's much clearer. Let's assume that we have a destination called as home fragments. We have an action in home fragment called launch member details action, which launches member fragment. Let's assume that's the case. So what happens is you get a class called as home fragment directions. It's automatically generated. And there is a method that's automatically generated as well, which takes in the arguments that you have already created. Remember this? So we have a members fragment, and we have an argument. And this is the generated code for that. So you can just say home fragment directions dot launch member details action dot, and you can pass in the member ID. So here the member ID is the type of type that you have specified in the XML. So if you specified an integer, it's going to take an integer, and there is no way you can pass in a string over here. And you can just say navcontroller.navigate and pass in that action. In the destination side, things get cooler. You can, if you're using Kotlin, you get this nice little feature where you can just say member details fragment the destination args by nav args, and you will get the member details fragment args automatically created for you. You don't really have to get the bundle, get the argument, or manipulate that stuff. But if you're using Java, or if you don't like doing this, then you probably have to do from bundle. There is a static method called as from bundle, and you can pass in the bundle there. So for fragment, you can pass in get arguments, and that should work. Deep links. Navigation library provides support for explicit and implicit deep links. And there is also a principle of navigation where deep links are supposed to behave differently in terms of backstack handling. We'll see about that now. Explicit deep links are cases where you want to expose some destination through a pending intent. So explicit in the sense you mention which destination opens up, right? And this is useful in cases like notifications, app shortcuts, and widgets. So there is a class called as nav deep link builder, which is used to create a pending intent for you. So what you can simply do is create an instance of nav deep link builder, set the graph, and then set the destination, and If you want to pass any arguments that you got from the remote notification, you can just use that and say .create pending intent. And that should give you a pending intent that you can use anywhere else, right? This is what does this mean? I mean, the context, that matters a lot. Because, I mean, if you're passing in an activities context, then yeah, if you're passing in an activities context, then that activity will be used to launch your application when the pending intent is used. But if you're passing in a fragment, I mean, if you're passing in a context from a view, then it's not really possible to open up your destination. So that's when what navigation components will do is it will query the package manager for your launcher intent, and then it will take your app. I mean, it will open up your app and then go to your destination from there. You can also, if the context is like too much for you, then if you have an instance of a nav controller with you, then you can just say nav controller.create deep link, and that would give you a instance of nav deep link builder, and that's about it. Implicit deep links are something that we always want to use in our applications. It's where you listen to open actions on most of the URLs that is passing around in the OS, and you want to handle some of them. So if you're Facebook or if you're Medium and you want to open up your own links in your own app, then that's how you do it, right? Implicit deep links are supported by navigation components as well. We used to do that with intent filters on our manifest and then listening to the arguments that are passed. But this way is much easier and reduces a lot of boilerplate. What you simply do is you set deep link app URI and just say what URI you want to listen, and that's about it. What you can also do is you can have placeholders over here. Placeholders are represented within curly braces. So if you're handling something that's a dynamic URL and you want to get some part of the URL out, then you can have that placeholder as well. What happens is the backstack is handled based on the flag activity new task. So if this flag is set, then the backstack will be created. Your application would be opened up on its own task. The backstack will be created as if the user opened up your app, went from the start destination to your destination that you have specified in the deep link. If this flag is not set, then your destination would be opened up on top of the calling application's task, so that when you press back, you go to the calling application and not inside your own application. So that's the only difference on how the backstack is handled for deep links. And you have to remember to add your nav graph in the Android manifest. The thing is, we write a couple of lines of intent filters for each of the URL that we want to handle. And if you have like hundreds of activities and all of your activities listen to a different set of URLs, then the manifest is going to blow up. This is a single line where you just say, this is my navigation graph. It will take care of my deep links, and manifest will just know which one to open up. So we saw all the basic stuff. We saw what a destination is, what an action is, what deep linking is, how to pass around data and all the stuff, right? So how does it all work together? How do you navigate from one destination to another? So that's where nav controller comes into play. We saw what a nav host is. So we added a nav host fragment in our activities, and it took care of all the destinations. So it is like an host. But nav controller is the mastermind behind everything. So each nav host would have a nav controller, and you talk with the nav controller. You don't explicitly speak with the nav host fragment. You just talk to the nav controller, and the nav controller would take care of populating the fragment that in the nav host. That's the basic concept of nav controller and nav host. And it's pretty much easier to get an instance of a nav controller if you're using Kotlin, which I hope you do. There are excellent extension methods on fragment, view, and activity. So you just say find nav controller, and the Kotlin works its magic, and it gives you an instance of nav controller. So you don't really have to worry about anything. So it's not 3 lines of code. It's just 3 different codes here. If you're using Java, you're still not that bad. You just have to use a static method under navos fragment or navigation, and that's about it. So you just get a nav controller, and you just call navigate method on the nav controller, passing in an ID or something else. We'll see about that. Navigation using destination ID. So as we saw, there is destination, there is actions, right? So how do you navigate to a destination using a destination ID? It's pretty simple. You just say find nav controller dot navigate and give it an destination ID. That's about it. So you don't have to create a intent. You don't have to create a you don't have to call start activity. You don't have to do begin transaction, end transaction, or something like that. So you can forget all about that. You can just say find nav controller dot navigate, and you'll be done with it. There are the navigate method has a lot of navigate has a lot of overloads. You can pass in a couple of arguments here, but this is the basic implementation of a navigate method. So how do you use an action? As I said, navigating through destination is not that great because you cannot add a lot of metadata in it. Actions has a lot of metadata like backstack behavior, sorry, and animations and all this stuff. And that's the reason you can just replace the destination ID with an action ID, and that's about it. So you can just say nav controller.navigate with an action ID, and that's it, right? You can also do navigation with URI if you're into that, and if you really need that. So as we saw earlier, you just put in a deep link, and you just say find nav controller.navigate and pass in the URI. What navigation components will do is it will just look up for the deep link tag and open up that particular fragment. And if you have got like placeholders over here, and if you have got like arguments over here, then this URI will be parsed, and your destination fragment will get its own arguments class as well. The next thing that we are going to talk about is backstack manipulation. And there are three different ways that I could think of where backstack could be manipulated by us. Because backstack has always been a pain for us from the beginning, and that's the reason we always hate fragments. We either go with activities or just leave under development at all, right? This sort of like helps out with the navigation. Fragment navigation. What you can do is specify pop-up2 and pop-up2 inclusive attributes on an action, and you can specify which destination you want to pop back to when the user presses back from a particular destination. Pop-up2 is used to say which destination, and pop-up2 inclusive says whether that particular destination gets removed as well or not. Let's see a quick example so that it doesn't make a lot of mess over there. So let's assume we have three different screens: homepage, login screen, and register. I'm not that good with real-life examples, so this is what you get. When the user lands on your homepage, your backstack has home. When they get into login, there is login, and then register. So all is good for now. But what happens when they press back is, under normal situation, they would see login screen, and then when they press back again, they would see homepage. But you don't want them to see login screen. You want them to see the homepage. Then you say pop-up2 ID home. Then what happens is it skips the login. You just say, when the user presses back, I don't want to do anything. Just skip everything in the backstack and let me take the user to the homepage. That's about it. That's how you use pop-up2. If you're doing this in cycles, if your user is crazy like I am, and if he's doing home, login, register, home, login, register, home, login, register, then you get a lot of home in your backstack. So when the user at last finally presses back to exit your app, he gets to see your homepage a lot of times. That's cool. You get the user to be in your app, but still, they are going to get pissed off. So you just say pop-up2 inclusive true. That means what happens is it always retains one instance of the pop-up2 destination, so that you don't get multiple homes. You just have one. That's it. The next one, if you want to really do on back press sort of thing from your navigation, you just say nav controller.navigate up, or navcontroller.pop backstack. So these are the methods that you have to pop manually, pop destinations manually. And pop backstack returns a boolean, which says, which is true if there is a destination to pop back to, but if you're on the final destination, if you're on the only destination on your backstack, then pop backstack returns a false. That means you have to handle that, and you have to close your app or show a nice little prompt saying, "Are you sure you want to exit?" We all like that, right? There is also custom back navigation, where the component activity, it's a base activity for fragment activity, which is the base for app compat activity. So the component activity has got a nice little on back press dispatcher. And what you can do is you can get an instance of this and say add callback, and add an instance of on back press callback to that. And you can handle any back presses over there. So this is preferred than overriding on back press on your own and doing stuff. And it's preferred because it is lifecycle aware. Whenever, if you add a callback and then you forget and the user leaves your activity, then the callback doesn't get triggered anymore. And it's based on a stack where, the last added callback gets called first. And if it's enabled, then they are the only ones that get the callback event. If they are disabled, then the event is passed down to the next one in the stack as well. And there are cases where you want to reuse a piece of flow in your navigation graph. Sorry. And what happens is, let's assume that you have a login flow or a registration flow where you take the user through 4 or 5 set of screens for no reason what, and get them to register into your app. You want to reuse that piece of code. You want to reuse that flow everywhere in your application. Then you can do that with the use of nested graphs. So nested graphs are similar to all the navigation graph, except that it lives inside a navigation graph. That's it. So this is how the nested graph in XML would look like. So you have a navigation nested graph ID. That's the cool name that I could come up with. And that's inside another root level navigation graph. Right? And this is how it would look in your navigation graph. You can double click it, and it would open up the nested graph destinations as well. This is useful in cases of deep link as well. So if you're deep linking into this into a destination that's inside, then it sort of manipulates the backstack accordingly. So the start destination of the nested graph gets added to the backstack as well. Then we all use libraries. We all use multiple modules. So modularization has been popular right now with us. Let's assume that we have 2 different modules. One is and one has got navgraph.xml, and the other one has got login graph. As I said, I'm not too cool with real life examples, so this is what I could come up with. And what you can do is you can navigate from one of the destinations in one module and to one of the destinations in other module as well. So multiple module navigation is supported by navigation components. You just have to specify the ID of the navigation, the other module's navigation, and just include that particular navigation file resource so that the component knows where to look for that navigation graph ID. This is one of the newer features where you can navigate across dynamic feature modules. So dynamic feature modules, if you don't understand, it's where you dynamically download a particular module, a piece of code into your application as and when when the user is using your application, so that you don't have to bundle everything when they first install the application. For that, you just have to add a nice little Maven URL over there, and then you just say you want to include dynamic feature fragment, and 2.3.0 snapshot is the version right now. You can use this, and there are a couple of changes that you need to make to work with dynamic features. One is, remember the activity, the fragment that we added in the activity, the navos fragment. The dynamic navos replace that with a dynamic navos fragment from this package. And then on all the destinations in your dynamic feature module, just add this particular attribute. So in your activity, fragment, and dialog destinations of your dynamic module, just say app module name and specify the module name. That's about it. So you just do these changes, and what happens is the navigation, when you navigate to one of the destinations in the dynamic feature module, the navigation library takes care of downloading that module from the Play Store for you. It shows a nice little progress bar over there. Progress fragment over there. The progress fragment, of course, is customizable as anything in Android. And you can also use dynamic install monitor. So that's a piece of class where you can add a callback to, and it provides you callbacks on, whether the download is complete, whether download has got any errors, or if you want to handle all the UI yourself, you can use dynamic install monitor. So it's still not even in alpha, and I haven't really gone through it much. But this looks to be a cool thing added in 2.3.0 of navigation components library. Just going to skim over this part. We already have this is much better if you're going to use a single activity architecture where all the destinations are a fragment, because you get a nice little, nice big graph of all the screens in your application. What happens though is your toolbar, your bottom navigation bar, your drawer layout, all the things that you have sort of has to change according to all the destinations that you have. You don't really want a back button on your homepage, and you want to show some other icons on your toolbar, or if you want to change the bottom navigation bar, then you can do that all with the following methods. The support for toolbar, the navigation components library support toolbars, collapsing toolbar layout, action bars, and what you can simply do is use the class called as app-bar configuration. App-bar configuration takes in multiple parameters, right? The constructor has, there are different constructors as well. What it essentially does is for all these, you need the back button, right? So on the start destinations of your navigation graph, the back button shouldn't show up. It shouldn't show up. On other screens, the back button should lead you through the backstack. So that's the philosophy behind navigation. And when you create the bar configuration and link it with, set the nav controller with your these views, then what happens is the navigation up button sort of automatically appears and disappears based on whether that screen is a start destination or not. You can configure which screens you want the back button to appear on by passing in a set of destination IDs to the app-bar configuration as well. Menu items, you can, if you can add your, if you can make your menu items ID and the destination's ID to be the same thing, then you can just say menu item dot on nav destination selected, and that should open up the destination that you want. So if you can make the IDs the same thing, then it would work. Setting up nav drawer and bottom navigation bar is almost the same thing as well. So if for the bottom navigation bar, you have a menu XML file, if you can name the IDs the same as that of the destination that you want to open up, then you just say setup with the nav controller, and it sort of opens up. The thing is, you can also listen to all the navigation changes. You don't have to really link your UI. If your flow is something different than what is supposed to be, you can just say add on destination change listener, and you get the destination ID, the current destination that's showing to the user. And you can do anything that you want. You can hide views, you can transition views. It's up to you. So you can play with it as you want. The last thing is sharing view model. As I said, you don't really have to scope your view models to your activity or fragment anymore. You can scope it to your navigation graph. So this is really useful in cases where you have a flow. Let's assume, again, a registration flow where you have 4 screens and you want a shared view model between them, but you don't really want them to be scoped to your activity because you don't want that view model to be alive once the user is out of the registration flow. It's going to take up some memory, right? What you can do is you can say by navgraph view models. So that way, if your registration flow is a nested graph or a graph on its own, then you can just say by navgraph view models and pass in the ID of the navgraph. That's it. So your view model will be created when the user enters the destination, enters the navigation graph, and it will be destroyed by the time they exit the navigation graph. If you're using Java, then you can just say view model store owner and use view model provider to create your view model. That's about it. So what could be improved? I mean, we have seen a lot of improvement in 2.0 and above. So what could be improved? View pager support is one of the things that came to my mind. It really isn't navigation view pages or not navigation. It's just swipeable views. I understand that, but I mean, I thought it'd be cool if there could be a way where I can see my view pages in the navigation graph as well. And I don't think there is a way to pass data back to one of the destinations in your backstack, unless I mean you have it in your view model and then fetch it from the view model back. But I mean, it would be great if there is a way to like set. I mean, similar to set result and other things that we have been used to. And then 2.3.0, as I said, still in pre-alpha, but it would be great to have deep link support. Right now, 2.3.0 doesn't have deep link support. So that's it. We are hiring. We are working on a lot of cool, interesting Android projects. So if you're interested, just get in touch with me. Thank you so much.